area of a trapezoid. So the formula for this one is area, which is equal to 1/2 times the height times the addition of the two sides. So let's go over what all of this means. So let's look at what trapezoids could look like. Right, they can be rotated in all these different directions. So now let's go over what this all means. So what's A and B, right? These are just the sides. And A and B is what is parallel to each other. So when we look at this, right, parallel means they'll never touch. They kind of go on forever on these two lines, essentially, if they were to keep going as lines, and they would never cross. So those would be, so this could be A and this could be B. Or for this trapezoid, this is right here, this could be A, and below could be B. Right, so these are what's parallel, and this is what A and B is. So A is on one side, B is the other one. Now let's look about height. So height, well, this is kind of between these two A and B, right? Whatever we mark them to be, either one side's A, one side's B. But what connects them, that distance right here, would be considered the height. And so for this one, it's actually part of the side of the trapezoid, which would be here. So this would be the height. So it's the distance between those two, right? And it's just going on a straight line between the two. Now let's look at some examples. So example 1, let's find the area of the trapezoid below. So let's go ahead and rewrite. Now, let's go ahead and say A. Well, A could be right here, right? This top half. And then this bottom half could be B, because these are the lines that are parallel. So A could be 10, and then say B is 16. And then what's the height? So let's go ahead and find the height. Well, it's this line that connects them, right? It's this vertical line. So this would be considered to be 9. So the height is equal to 9. So now let's go ahead and plug this all in. So we have area, which is equal to 1/2 times the height. So that would be 9 times, and then we're going to add A and B together. So 10 plus 16. So let's go ahead and start to solve this. So 10 plus 16 is 26. So we have 1/2 times 9 times 26. Let's get our calculators out. So we have 9 times 26, which is equal to 234. And we just need to go ahead and divide that by 2. And we get 117. And then this is in inches, right? If we go back, and it's inches squared because it's the area. So let's do one final example. So example 2, we're going to find the area of the trapezoid below. So area is equal to 1/2 times the height times A plus B. So let's go ahead and look. So A and B, well, those lines are parallel. So this one and this one would be A and B. And then what's our height, right? Our height looks to be right here. It's what's connecting them. And that would be 4 inches. So let's go ahead and plug them all in. So we have area is equal to 1/2 times the height. So this 4 inches times A plus B. So 7 plus 9. And then let's go ahead and start to solve now. So we still have 1/2 times 4 times 7 plus 9, so that's 16. Let's get our calculators out. So we're going to go 4 times 16 first, right? So we're essentially, and then we can multiply it by 1, right? But that just means we're just going to end up with 64 again. And then, since we have 64 on top, and then we have 2 on the bottom, we can just go ahead and write divide by 2, because that's what we can look at the fraction bar as. So 64 divided by 2 is 32, and that would be in, once again, inches squared.